So a lot of what I did at Tesla was help the machine learning algorithms understand how to look at something, it's vision based, and determine if a new part or car or adhesive, glue, if it meets the definition of ready. And then if whatever value added steps were done meet the definition of done, because those are automated tests. Just like in software, if you have fast automated tests, you can experiment quickly. That drives this whole thing. Oh, Claudio, you're awesome. Here, I'm going to type that in the chat. Claudio, you are awesome. So you have these agile cells, these agile lines, and because they have really good artificial intelligence, telling the definition of ready and definition of done, you can branch dynamically back and forth between versions of the vehicles. Now, this does mean that every single vehicle is potentially unique, potentially every single one, because you have multiple of these agile lines running at once. In fact, in some areas, you have tens of them. And they're making different versions as they ramp up. So you have a mix. And this is really confusing to a lot of analysts, where two people will buy a Tesla on the same day and get very different cars. And this happens every day, forever, and it's by design. There's not a single line. There's hundreds of lines, and they dynamically feed back and forth between each other. And this is much more natural. If you look at a human body or a single living cell, nutrients don't flow in just one direction across a cell. They flow all directions based on need. It's very fast, and it's very dynamic. Well, Tesla actually flows in a similar way. And the reason that can work is because of these automated definitions of ready and definition of done pairs. And running Agile at Tesla, that's actually what I spent a lot of my time on, is refining, updating, understanding the DOR and DOD by joining these lines, by doing this work, not by like auditing it with a clipboard, but by joining and doing this work and then saying, is our DOR appropriate? Is our DOD appropriate? And we would do a Kaizen. And we would do that about every 3 hours. So this is the most important concept if a company wants 3-hour projects, for example, from design to done, is it's difficult. How do they manage backward compatibility with so many versions? Awesome point, Pedro. I'll zoom out for a moment because I do want to take that question. So if you'll bear with me, the answer to that isn't here in the pilot line in the factory. The answer to that is down here in maintenance. And here's the answer. As leaders of Agile organizations, we have to do something more to actually get the collaboration for which Agile teams are famous and which amplifies performance. We need to command and control something. In Scrum, we command and control the interfaces, where things connect. And everything else is left up to the teams. This creates the stable framework of Scrum across the organization while maximizing the innovation and self-management aspects through the Scrum roles on each team. From Scrum Master, the book, Chapter 3, Build. So here's how Tesla does it specifically. Tesla technicians are trained on the interfaces, not every module and the hundreds of versions. Here's an actual maintenance scenario. Step 1, Tesla Analytics detect a possible problem or the customer requests service from their mobile phone app. Step 2, a service car, and I'll scroll over. Here's what the service cars look like. So one of these cars, a service car travels to the customer car location and they swap the defective module as fast as possible in the field. For example, I was in Hawaii and I was having a cocktail at a hotel bar and I got a notification on my Tesla app saying an update to your charger port is available. It's free. It should take less than 10 minutes. may we do it to your car? And I pressed the yes button. And on the app, it showed me the Tesla technician come up and park next to my car at the hotel bar parking lot. And I was super interested. So I actually finished my Mai Tai and I walked into the hotel parking garage, and there's the Tesla car. And I talked to them. It turned out they'd worked in Fremont, California, the mothership before. So actually we'd worked in the same building previously. And they just swapped the entire charge port, and they were done in like 3 minutes. And then we talked for longer, but they were actually done in like 3 minutes. So I got a free upgrade in the parking garage of the hotel bar. So that's this step 2. Now that technician, it doesn't mean they're trained in the intimate details of the hundreds of versions of charge ports. It means they're trained in how to swap, like pulling Legos apart. Like a 3-year-old kid can pull Legos apart, but it doesn't mean they can describe to you every single type of Lego brick and every plastic they might be made out of. Well, tech support works the same way. So step 3, bring the defective module back to the factory for regression testing. Step 4, the defective module is recycled, whether that means repaired, re-engineered, melted down. It depends on what's appropriate. So Pedro, did I give you some information on your question?
Joe, general question, how do you want to handle this? You want to go through your prepared material and we discuss at the end, or should we interrupt you when things pop up?
I would way rather be interactive, because the entire prepared materials is 2 days, so we can't get to it all. So I'd rather, I wish we could. Join the class if you want to, if you have time. Dennis, you've seen most of this already. There's some new stuff from me being at Tesla. You might enjoy it, Dennis, even though you know a lot about what I thought I knew. But there'll be some new stuff. But I'd rather people ask questions and I try to zoom in on that piece so we at least get to people's area of interest, because the entire information that I prepared is a 2-day class. So let's zoom around. Please, Dennis, go ahead.
Okay, in that case, I'll shoot a question and you damp me down if I'm distracting too much.
You're too funny, Dennis. You're an expert in this. I don't know if everybody knows. Dennis is an expert in this. He actually leads these activities in a huge company in Germany. So thank you. It's an honor for having you here with me again, Dennis.
I'm trying to ignore the flattery. My question is the following. What you described, new product introduction, having a lot of variants, being able to introduce new variants very quickly. We discussed the maintenance side. Okay, we have to have known stable interfaces. Interfaces are the key. I see that.
Yeah.
Now, my question is, don't we need virtual twins as an essential component in order to be able to handle these variants and know what happens in the field, which cars to address and whatnot? Because I believe this is a key component that most, at least, of the European car manufacturers are still missing. There's not this concept of a virtual twin on an individual car level.
Dennis, I completely agree with you. And I'd like to try to even add some information to it, so you have the ammunition to have a good, useful conversation with your colleagues. So if we look at Xing or LinkedIn, they don't have 10 virtual twins, 10 digital twins of 10 possible users. They have a digital profile for everyone who has a Xing account and everyone who has a LinkedIn account. And in fact, I don't know how many people know this, but Xing, LinkedIn, Google, Twitter, Facebook, they actually have a digital twin of every human alive. So right about 8 billion around digital twins. So they try to model all humans alive, roughly. And what they want to know is, where do these people work? Where did they work before? Can we guess where they'd be interested in working next? Who have they worked with? Who are their friends? And to deliver their service, they also want to know, are they primarily using a laptop or a phone? Do we know what kind of laptop? Do we know what kind of phone? And because they have history, they know what kind of phone you used to have. So they can even guess how often do you upgrade your laptop or update your phone. And so they have this information about you and about, they guess everyone, whether you have a Zing account or a LinkedIn account or a Facebook account or not. I mean, they try to guess this for everyone alive. And they have a digital twin of humanity. And this is a scaled software problem. Well, Tesla has only made 2 million cars. So it's way easier. And yes, there's a digital twin of every single Tesla, including all the prototypes. But that's still only 2 million. It's not 8 billion. So it in social media terms, it's tiny. I mean, a 2 million user audience, that'd be an unsuccessful social media platform, right? Well, that's Tesla. And even if you go to a company like Volkswagen, they still don't make 100 million cars a year. I don't know Volkswagen's entire number, but the total number of all new cars made a year is like 64 million from every company. So Volkswagen's huge, but they're less than that. Maybe they're 30 million, something. So still, it's well within the numbers that social media is comfortable working with. And what you do is you have a digital twin of every product. Now that gets updated in real time by analytics, and really good analytics. Now, something that I wish Tesla did even better is I wish they had better customer interaction. Customers are very rarely, they are sometimes, but very rarely invited into Tesla to look at potential new features on a product backlog and give their opinion. It does happen, but I wish it happened a lot more. In exchange, what Tesla does do really well is analytics. So they know on every car how many people use each feature. What percent of the time do they use it? Do they use it when they're playing music with a fast tempo or a slow tempo so we can guess their mood? Do they use it when they're driving aggressively or driving extremely safely? Do they use it when they're alone in the car or when the car's full? Do they use it only when the child seats are active? And this creates really detailed, really rich analytics, kind of like what LinkedIn or Zing has. And those analytics drive machine learning that provides the likely backlog for teams to work on in these pilot lines. So Dennis, your point, I agree with what you said. I completely agree with what you said. And then I hope I gave some ammunition that helps you have a passionate and informed conversation with your colleagues.
Sure did. Let me just add a bit of context for those in the group today that are not coming from the automotive sector, so you understand what Joe was just telling you. I'm taking the opposite position, and I'm trying to tell you about the state of the art in current European car manufacturers. So Joe has described what Tesla is doing. State of the art currently is that each vehicle has a chassis number. This is unique to the vehicle. And this chassis number is in a database, and this database tells you the configuration of the car at the moment of sale. So if you change something later, you change the charge port to a newer version, like Joe told, that is not updated in that database. This data isn't here yet, and it is not even recorded in the manufacturing process, because if you really want to do this, you have to have fully what's called an Industry 4.0, Manufacturing 4.0. You have to have all this data automatically registered and connected to your vehicle during the manufacturing process. We are currently not doing that. The only company I know of in Europe that's doing that is Eagle from Professor Schuh, but I guess only Germans would know that one because it's tiny. Okay, and then I shut up.
Dennis, you're so awesome. Yeah, for most companies, this is unusual. So what's cool is for those of us attending Agile conferences, there's a lot of value we can bring to most companies. Most companies aren't doing most of this yet. So we Agilists have a lot of value we can bring. Remember, like, I don't know how many of you have been in the Agile space for many years, but remember an Agile software conference when we thought it was just software, like 10 years ago? Like there was a lot of software companies that didn't have any of what we're talking about. And now like maybe half do. Well, for hardware, it's like that again. There's very few. So we can really help. All of you can really help a lot of hardware companies. And a lot of them are looking for it now. So it's not a secret. A lot of companies are actively hiring Agilists into hardware now. It's just starting. The boom is happening. I had 75 people from Volkswagen in my last Agile hardware developer class. And then I had 50 people from more than that now, from a company called Ansys that does simulation. And they're awesome. Ansys is phenomenal. They do great simulations, saying, how do we get faster cycles to support our hardware clients? And then Schneider Electric is putting so many people through my Agile hardware developer class. And I just had another talk with some companies in the Netherlands and France. So it's growing in rockets and airplanes in Europe, but it's so new. They really want people who know this stuff. And so we can help a lot, because the state of the art for most companies is different. There's opportunity. Okay, I will go back up to the pilot line. The most important, I think, concept I wanted to talk about is this one. What does continuous delivery and continuous deployment look like in hardware? And what's weird is, if you cross out the cars and put software versions, this is the same diagram you would use for CI/CD and software. The difference is the compiler is the factory instead of a server somewhere, but it's the same. Continuous integration, continuous delivery is the same. So I tried to draw it in hardware, and this is the point. And the faster we can assess if an individual part meets the definition of ready and definition of done, the faster this cycle can go. And the faster a new team can ramp up around a new goal and deploy one or more tested, complete products, that's your sprint length. And you can have a faster and faster sprint length. Okay, I'll scroll down. Tesla does not officially or even unofficially endorse Scrum. They don't. Elon Musk does not care about Scrum. Elon Musk doesn't say the word Scrum. Elon does say Agile, actually quite a bit. And Agile is huge in Tesla. Scrum is not. I use Scrum when I launch new teams because it's really simple. There's only 11 rules. Everybody can learn it in 2 days. There's only 3 roles or accountabilities. It's really fast and easy. So I like Scrum, and I used Scrum a lot doing Agile at Tesla. Tesla does not care whether you're a Scrum team or not. So I actually like teaching Scrum classes. I certify Scrum Masters and product owners. So please help me earn a living. Take my class and recommend people take my class. But if you get that certification, it won't get you a job in Tesla. They don't care if you're a certified Scrum Master or a certified Scrum product owner. What they do care about is that you're comfortable acting on something you saw right now and trying to get it to done and installed on cars today. Now that's an Agile mindset. So it makes it really difficult for people who have been in traditional engineering organizations to work there. I mean, they have trouble. A lot of Tesla employees are young, but not all. But what they do have is an Agile mindset. And it's really hard to come from another automotive company and survive in Tesla, because the mindset is they expect you to act now and try to get it done before you go home, which is really different than, let's have a planning meeting about project funding. And I mean, there's none of that. I did not see a single PowerPoint or presentation of any type the entire time I was in Tesla. You just act. Now, there's a lot of machine learning, and the machine learning helps you determine quickly, are you acting in a way that's going to not just waste money? A lot of machine learning there is around financial efficiency. How much money is your team consuming versus the guest value coming out? And so you have these efficiency numbers per Agile pilot line constantly. But what I'm sharing here is a diagram of all of Scrum. And the point I'd like to make is Scrum is totally not required in Tesla. I still recommend it because it's so easy. You can skip it. You could do something else. What Tesla really is open space. If you've ever attended an open space conference, and if you've ever done mob and swarm programming, or in this case, swarm engineering and swarm building, that's really what Tesla is. It's hardcore agile. But Scrum helps, especially for people trying to get used to it and get comfortable. Now, what makes this really work is definitions of ready and definitions of done. And I will split definition of ready into what we usually call definition of ready. I'll call that the developer definition of ready. And that means the team understands the goal well enough that they can start. I'll add another definition of ready that I haven't seen many agilists talk about. That's a business definition of ready. And that means, have we vetted this thing enough that it's funded? Now, in a lot of less agile companies, the business definition of ready is a several month-long approval process to get something funded, in some cases years. Well, Tesla doesn't want to take months or years. They want to act within a minute. So how do you responsibly make a funding decision and not just be chaos, right? Well, this is where machine learning comes into play. And Tesla talks about this openly on their investor conference calls, and none of the investors understand. In fact, they get angry. They're like, why won't you just tell us how much money you make per car? And Zach Winkerhorn, the CFO, says it's a dynamic algorithm, individual per car, and teams see their own financial efficiency, and the trend is up, that's what we need to know, that every second we're making more money. And investors say, that's good, but we've never heard of a company doing it that way. Give us a number of how much money you make per car and how much money you'll make per car in 5 years, so we can make a 5-year outlook. And Zach says, yeah, we don't even calculate that. What we need to do is have a real-time metric to the people doing the work that shows if they're getting more or less financially efficient. That's what we need. That's core business principles. And the investors are like, but how do I make a 5-year predictive waterfall roadmap for you? And Tesla's like, you can't. and the investors get really angry, or at least really confused. And this happens every single investor conference call. I recommend listening to them if you haven't. They're hilarious if you're an agilist, because you hear the clash of agile and waterfall every time, and it's worth billions. It's worth actually more than 100 billion as these two groups clash. But so the funding part is what I'll call a business definition of ready. And that means you have a green light in seconds that says, yeah, it's fine to spend money on this. And anyone can propose additions to the business definition of ready anytime. And the machine learning algorithm actively proposes new project candidates in real time all the time. So then you form a swarm around these and attack the work. This might sound insane for people who have been in traditional manufacturing for any length of time. But for those of you who have ever attended an open space conference, this likely sounds very natural. Hey, and here's some pictures from Bosch. Dennis, here's your railroad prototype. Anything you want to say about this, Dennis? I learned this from you. This isn't my work. I mean, here's me with the chair and CEO of Bosch, Volkmar Denner. I'm super proud of this. This is a superstar moment for me. But even cooler than that, here's what the teams showed me of these sprints they were working on. And this is Dennis's work. Dennis is famous in this company for speed of innovation, whether he acknowledged it or not. He's way too humble. Dennis, is there anything you'd like to add?
I can briefly say a couple of sentences to what you're seeing there. Actually, it wasn't my team. It was a team I coached about a year or a year and a half before they went into producing this. What you see there is from the rail department. So they were working on helping locomotives that are shuffling freight trains to and fro and configure these freight trains in the big ports. So and what they did was they introduced a camera system that was meant to avoid accidents by hitting people, hitting obstacles, hitting other trains, whatnot. Because usually these trains are remote controlled by a person walking along the line, along the track with a controller. And now this person has a camera view of what the train sees. Now you realize these trains are quite hard to stop once they got rolling. So it's really a good thing if you identify obstacles early on. And that's what these cameras are meant to do. And they are meant to do this in all kinds of weather. And they are meant to do this for many years without maintenance or with very little maintenance. So we had at Bosch hardware that could do this from the automotive sector. We had a lot of video cameras, radar cameras, and whatnot. And the task of this team was to transfer this to the rail world. And there's more to do than you would expect to do, but I'll leave all this out. What you see is here the main challenge is try to design a housing and a mounting that is maintenance-free, can be mounted by railroad personnel on the locomotives and reproduce a reliable signal in all kinds of weather. And what you see there is a progression of prototypes. So the first prototypes were simply taking automotive hardware and putting them in rather large and cumbersome boxes, testing the main hypotheses, namely, we need a wiper and we need a window, and it should be this and that material, and we need these mounting points. And then in the top view, you see one of our engineers testing this on the locomotive and showing how they try to figure out what heights this device needs to go to, how these mounting points correspond to what you really find on the locomotives. And then essentially what you see is a generation of different prototypes. So sprint by sprint, they exchanged cumbersome material, large material by smaller stuff. They tried out different wiper materials, and in the end went for the third from the left is a 3D printed casing. So the first two were manually constructed from standard materials, off-the-shelf materials. The third one is a 3D printed casing that is rather going towards the final product. And the last one is then essentially close to the final product, but still in a rapid prototyping fashion produced.
These less than a year hardware projects are not unique to Tesla or SpaceX or Neuralink or the Boring Company. This is Robert Bosch GmbH, a massive, established, high quality European design, engineering, and manufacturing mega company, a very important company with more than 100,000 employees. So a lot of people's paychecks and families benefit from this company. And they're also doing some fast hardware, is the point I'd like to make. What I was really impressed by is when this team told me every single one of these versions of prototypes was put on a locomotive and tested. So they didn't keep it in their lab. They actually had a real feedback loop. And more information on that when we take the class, because I'll just have more time. But here I'd like to say, what I'm trying to present here isn't only in Musk companies, at least some of it. Some rapid innovation, at least in prototyping, is happening in established, awesome, very high quality companies. And some of you may or may not know, many of the parts for the Tesla Model S are made by Bosch. I remember meeting the Scrum Master of the steering rack team, the autonomous enabled, autopilot enabled steering rack for the Tesla Model S. And the Scrum Master handed me one and I was holding it. This is before I went to work at Tesla. And they were telling me about the sprints they run to make this steering rack. That's a Robert Bosch GmbH part, which you can see. So I'm not saying anything crazy. You could actually take apart a Tesla Model S and you'd see it. I'll scroll down. Another important aspect, if you were actually going to do this in hardware.
Just a brief remark there.
Yes, Dennis.
What you just mentioned was a lesson about market pull. There's a reason why they worked in sprints, because that was a condition made by Tesla.
And Bosch delivered. So when you're a company with a partnership with another company like Bosch is with Tesla, yeah, pull can work. And I think there's an opportunity. If any of you happen to work in Daimler or BMW or Ford or Nissan or Toyota, I think you have an opportunity to collaborate with your suppliers and see if some of them will join you in some sprints and sprinting. Bosch did. Now, each of these sprints, how to say this the right way? There's a misconception, or really companies cheat, where they'll have design sprints and test sprints and prototyping sprints. That's not what I'm talking about. I'm talking about going all the way through till in production, installed on, in this case, cars that customers are going to buy. That's one sprint. And so sprint length means this diagram I'm showing, from the project plan through the maintenance model. That is a sprint. And for Tesla, that used to take a year. There were year-long sprints. And for SpaceX, it used to take a sprint. And that's still really, really fast. It was a year to go through. And then Tesla and SpaceX did what a lot of you do in your companies now. They made the value stream map of these phases and said, where can we save time without degrading quality or risk? And that's where some automation comes in. Can we automate some of these steps responsibly? That's where some level of vertical integration comes in. Well, this supplier has an 8-month lead time. Can we bring it in-house and have less than an 8-month lead time? Or can we switch suppliers? Not necessarily only which is cheaper, but can we rank suppliers by lead time and then calculate that versus cost, and have a happy medium. So these sprints then can shorten. But when I say sprint, I do mean all of these phases. And you saw the pilot line up above that's going through all of these phases for a module, from definition of ready to definition of done. And I'd like to show you what one of these actually looks like. So I'm still not allowed to share photos that I took in Tesla. I hope I am at some point. So what I do is I follow Elon Musk on Twitter, and I wait till Elon tweets something that I can talk to. And then I include it. So this is a tweet from Elon. I've got some pictures that are even more clear for what I want to talk about, but I don't get to share them. But I can share this one because Elon put it on Twitter. What's happening here, it looks like you're seeing general assembly, and you are, but you're also seeing Agile compiling. And this picture was actually tweeted a while ago. Dennis has seen this picture. What's happening is these robots are putting a car together, but the parts they're holding are different than the car they put together before. The parts these robots are holding change about every 3 hours. About every 3 hours, these robots hold parts they have never held before. So what makes that work well for us Agilists? First, the robots have flexible hands, and that does cost more. We call them end effectors, how the robots grip stuff or suction onto stuff. Those are flexible. They can hold different parts because the parts change regularly. If you're an Agilist in hardware and your production line is not flexible, you'd have to shut down the production process to retool to hold different parts. That's more expensive to make change. Your sprint length is going to be longer because it includes a factory shutdown per change. So to reduce that time, when you can make the investment, you do want flexible end effectors. So your roboticized steps can have a faster pace to make change. That's step one. Step two, how these parts connect is really important. That's called the interface. And the interface can change anytime, but it needs to change the same time for two parts that share an interface, or else you have a car that fails to integrate, a car that fails to go together, right? And you don't want that. That's expensive and that's wasteful. So the interface changes anytime, but only when the parts on both sides agree on the time. Well, robots don't care how complicated the interface is. They're fine. As long as it's not jiggly like a bunch of loose wires, as long as it's relatively rigid, they can put together really complex stuff. But humans slow down when the interface is complicated. We call this cognitive load. And to reduce cognitive complexity and cognitive load, to make things easier to think about, the interfaces are made as simple as possible. So the mating structure between these parts is generally a flat seam, or almost flat. So these parts fit, and then they're spot welded, line welded, adhesed, riveted, depends on the part. That's not for the robots, and it's not because it's necessary for engineering. It's to reduce cognitive complexity, because you want people comfortable making changes to these parts anytime, not starting an analysis phase of what would it mean to retool one of these parts. You want them to feel comfortable walking up and making a change. Now, these parts are really complicated, but the interfaces are intentionally much simpler than they need to be. Now, Elon says, sheer magnitude of the entire production system is hard to appreciate. Almost every element of production is more than 75% automated. Only wire harness and general assembly, which are less than 10% of production costs, are primarily manual. And then I added to that automation in software and hardware and management with test in the loop is in fact the answer. Humans are for creative problem solving. Automation is for everything else. And you put these two things together and you start to, I think, see where these 3-hour sprints come from. Now, Pedro, yes. What happens when you need to change the interfaces? How fast are their cycles? I'm curious about how the end-to-end tests are managed. Awesome point, Pedro. Pedro, I used to think you really don't want to change the interfaces because I thought it would have a ripple effect of revalidation across the entire system. So I used to advocate for a large upfront architecture plan to define the interfaces and hold them for as long as we could. I used to advocate for that. I don't anymore. By working with a lot of real companies really doing this, they have taught me it's fine to change the interfaces anytime, as long as the parts and teams on both sides of the interface agree on when, and they deploy synchronously. And I'll say these interfaces do change multiple times a day, which is really fast. But as long as the timing is coordinated, they can change anytime. Again, what makes fast change responsible is automated test on 100% of the product. If the factory is currently set up to test 1 out of every 1,000 cars, you can't make a change more often than 1 out of every 1,000 cars. And in fact, you want to make a change 1 out of every 100,000 cars. So you have 100 tests per batch to establish a confidence percentage. Well, that's how most manufacturing works, right? Well, you need to test 100% of your product if you're going to introduce change at any time and introduce change quickly. So really, automated test is a first-class citizen. It's so important that is the bottleneck, speed-wise, to production. Pedro, did I reach your question, or did I misunderstand your question? Oh, absolutely. You're totally welcome, Pedro. Good.
Joe?
Yes.
I have a question. I
Yes.
know that is kind of hard to answer this, but we know that automation is very important in software and in hardware and in management, as you said. But how to change that mindset that if we automate something, we can remove that employee from the company, not to put him or put her in creative processes. What do you think?
Wow. Cesar, you hit it. So a company, I believe a company that's comfortable with dynamic self-allocation, with self-organization, is going to have no problem keeping people, because people are normally dynamically reassigning, even self-assigning to different work. But a company that uses spreadsheet human resources, where they say, we have analyzed your skills and we will place you somewhere. So you don't have self-organization. You have like a project management organization assigning people. They'll hate this because they'll be needing to update their skills matrix more often than they could even make an assignment decision. Yeah, so a company with project assignment and people assignment, or even worse, matrix management, multiple project assignment per person, probably would not survive this, to your point, Caesar. Now, here's the really hard part. I'm going to zoom out here. Right now, we're just in Model 3 assembly, the pilot line. Really, every part of the organization changes to make this work. And I think that's the point you were just making, Caesar. Contracts change, our definition of done and sprint review and retrospective changes, the maintenance model changes, how we do review changes, product planning changes, how we estimate changes, how we refine changes. Right now, I'm just talking about manufacturing. But this is part of an ecosystem of change that actually makes a lot of sense if you happen to have an agile mindset. And Elon does. So it's not like Elon said, we need to get agile. Elon said, we should have a flexible company that prioritizes a fast pace of innovation. And so all these agile practices fit. But if you just try to introduce automation into a company that's based on assignment and off self-management, yeah, they probably will say, oh, we can save money and fire a lot of people. I mean, you already have a fundamentally broken mindset running the company. This is why I'd like to see more agilists at agile companies, not trying to fix their company, but starting new companies. I'd actually like agile conferences to be innovation hotbeds and where we meet people to start companies with, as opposed to trying to convince somebody. Okay.
You're right.
Maybe. I mean, it's one maybe right vantage point, but there's probably other right points of view too.
Yeah, thank you. Thank you very much.
I'll scroll down. Now, I'm really lucky. Before I worked in Tesla, I did work with Bill Gates directly. I was a developer in Microsoft, and I became a Scrum Master for Bill Gates when Bill was starting the Bill and Melinda Gates Foundation. And the Bill and Melinda Gates Foundation is social good projects like, can we eradicate polio? Can we increase the number of babies born globally that survive and with healthy mothers? Like that's the backlog. It's these huge non-software problems. Yeah, there's some software involved, but it's not primarily a software problem. And I was a Scrum Master for that. And Bill tried to teach all of us a lot of things. Something he was successfully able to teach me was execute as much of it at the same time as you possibly can. In fact, Bill started every single meeting I was in with Bill with, how much of this can we do in parallel? Now, as someone who's trained as a software developer, this made a lot of sense. This is object-oriented architecture for polio vaccinations or whatever the idea of parallel execution, where you need parallel executable threads, which means you can validate if they're testable. I mean, for those of you who do processor design or multi-threading or hyper-threading or Hyper-V or virtualization, each of these threads has to be a complete functional unit so you can validate it was successful. Otherwise, you can have a bunch of parallel garbage, right? So parallel threading, part of it is you validate before you put the threads back together. They are fully end-to-end complete waterfalls, basically, full projects, right? That's what parallel execution is. Well, and that's what made Bill, depending on the day, the wealthiest person in the world. Is that, like, really that. It's looking at something you want to do and cutting it into parallel executable pieces and running them all at once. And that's Bill's approach to the world. And it's incredibly successful. And it's what processors do every day. You know, if you look at an Intel i7, that's what it's doing. Well, that's what Bill does with management. And when I teach Agile hardware, this is really what I'm trying to teach. I'm trying to teach how to split a hardware problem into parallel executable projects that are not dependent on each other. They're parallel executable. You can test them separately. You can deploy them separately. And as long as the interface is compatible, you can put them all together. And here's what it ends up looking like. It looks a lot like what Henrik Nieberg showed us years ago Spotify was trying to do at the time. And Spotify's moved on since then. Spotify does even cooler stuff now. But the idea of these parallel executable module teams is basically what Tesla's doing. And it's what I tried to learn from Bill. And you can have tribes and guilds and squads if you want. They're actually not terribly important, in my opinion, in terms of execution. But they do help keep some knowledge sharing across people with common skills. Because you don't have a software group anymore. That's way too slow. Then every module that needs software is waiting on the software group. You don't have a procurement group anymore. It's way too slow. By definition, then, every group that needs procurement is in a queue for procurement support. So, that's a broken model, right? So instead, to make these projects parallel executable, they have their own software development. They have their own procurement. They have to. So these are each like little companies, fully independent, healthy, funded companies. And they are what's called full stack. They try to have every skill base with redundancy that they need to go all the way through the waterfall from end to end. And it looks like what my best friend, Paul Takin, rolled out across ING Bank. And it looks like what Henrik Nieberg told us Spotify was trying at the time. Now, I was super lucky. I did later work with the leadership team at Amazon. And Bezos still stresses, and did at that time stress, small team size. Now, Tesla has some teams that are 50 people. So how does that work? Because we know if you have 3 people, they have 3 communication pathways to try to understand the problem and innovate the problem. So that's ideal for rapid communication. By the time you have even 10 people, there are so many communication pathways, it's inefficient for them to all collaborate to try to understand the problem and offer a solution. So instead, they elect a leader. Humans do this. They will choose a leader. It actually happens right around 6 people. And this is where Scrum goes a little wrong. Some people start to make the product owner a leader. That's not what it's supposed to be. That's not the point. That means the team's too big. But just mathematically, not like I'm trying to judge, like just mathematically, that's what it means. And Bezos understands this. What Bezos wants is fast innovation, pretty similar to Elon Musk. So what Bezos did is he limits team sizes aggressively to 6 people. That's as big as you're allowed to get. And when that happens, they don't elect a team leader. They don't need one. Instead, they all collaborate like a round table. Now, Musk does the same thing, by the way, but Bezos, I think, is famous for this. And this is why. This is the math as a why. So we have these parallel executable teams that are trying to be full stack. They're trying to have every skill they need to be done and tested. and you try to have them 6 people or less. Well, how does that work with teams of 50 people or more at Tesla? If you've ever attended an Agile open space conference, this will feel very natural. You have an agenda and you self-organize around these agenda items. You use the law of 2 feet to decide which session you're going to go and dynamically change. You have butterflies and bumblebees and all the cool stuff Agile open space conferences have. Well, that's how Tesla operates constantly. So if the problem is understood and now it's time to execute, you can pile on 50 people. It's not about rapid collaborative understanding the problem. It's about execution. And you can have a leader saying, okay, now we think we get it. We need to execute the problem. What's a good example? All the ones I can think of are non-disclosure right now. I'll try to think of there's many shared examples. I'll try to think of one, but you execute as a huge group. Now, if 1 out of every 1,000 white cars is pink and you don't know why, that's not a problem for 50 people. That's a problem for 6 people or less. And they explore the machines, they explore the chemical mix, they explore the suppliers fast. I mean, like this minute. You want to solve it in less than 3 hours. You want to solve it in 10 minutes if you can. So 6 people attack that problem. Why is 1 out of every 1,000 white cars pink? And they try to fix it themselves. But if they think they see a test they need to run or a fix that requires a lot of people, then the agenda lights go on everyone's phone and on all the monitors saying, here's an opportunity. We need people to pile on this. Change the nozzles on all the paint robots. There's hundreds of them. Change them all now. And these lights go on and people self-organize around that. And then you can have a big team because the problems, at least this version of the problem is known and you can have a max execution together. I think that's the time we have. It is my honor and privilege to collaborate with you. There's actually only a little bit more of the pilot line. We're near the end. And if any of you are curious, I would love to have you join the Agile Hardware Developer Program anytime at your leisure. I just published this book in 6 languages. The first 50 pages of it are free on LeanPub. I just put that in the chat. And here is the link to the Agile Hardware Developer course. We do this on European time, the Americas times, and Asian time zones every month. I'd love to have you if you like to. It'd be my honor. It's my privilege to be part of the World Agile Forum and Experience Agile 2021. Thank you so much. If anyone likes, please connect with me on Twitter or LinkedIn or Facebook. I would love it. Thank you, everybody.
Awesome, Joe. Thank you.